Hello everybody and welcome to today's webinar, 5 APM and Capacity Planning Imperatives for a Virtualized World. I'm Frank Days from Correlsense, and on behalf of everybody on the Metron-Athene team and Correlsense team, we welcome you today. Before we get started, I just want to take a minute to go through the agenda. We'll go through 3 major sections. We'll talk a little bit about the challenges, the things that virtualization brings to you, and obviously the way it changes your IT infrastructure, the 5 imperatives as we talked about earlier, and then finally we'll end it with some Q&A. A little bit of housekeeping. We'll try to keep the presentation to 30 minutes or less as a favor to you guys so you can get on with what you're doing in your life. If you have questions, please feel free to submit them via the chat window during the presentation. We're glad to try to answer them. I'll try to poke my head up if a question comes in and answer it. If not, we'll take some time at the end to try to answer any questions you might have. And finally, Tom McEwen, who's on the phone line and the guy who sends out the emails and our producer today, will be posting the slides to the Correlsense homepage tomorrow, as well as the Metron-Athene guys will have a copy of it to post on their site. So let's get on to the presentation. First of all, challenges of virtualization. As we look at our IT environments today, obviously there are a lot of things that are going on at the same time. Regardless of whether it's virtualization, our businesses are changing, and that change is obviously trickling down to what we're doing in IT. Whether it's agile, release cycles, merging of businesses, divesting of businesses, the one thing that's constant in a lot of these businesses is the fact that things are changing frequently. Along with that, we can layer the increasingly complex multi-tiered architectures, service-oriented architectures, outsourced infrastructure, all kinds of different systems that are wreaking havoc on how applications perform and how you manage your IT environments. And then couple that with the environments that we're working in. The heterogeneity of our IT environments make things more difficult, and as we move more things to these virtualized environments to help us manage costs or help us with scale, you need systems, and your systems need to be able to adapt, and you need to be able to work in these things, whether it's cloud or virtual. One of the big things that's going on, and many of us are seeing this in organizations, is the move from physical to virtual. Again, from some of the things I talked about a few moments ago, whether it's scale economies of having multiple servers on one and getting rid of old servers and moving them to new. This shared virtual infrastructure can be a real cost savings for many companies. The downside to that is that there's also the risk of oversubscription and over-provisioning. It's a real risk, and people need to be aware of it. And also knowing what your neighbor's doing on that particular server isn't always necessarily apparent to you as you're managing your applications. Also, if you're moving from your dedicated server that maybe someone on your team manages to a shared virtual server that's managed by someone maybe not on your team, can create new challenges with keeping people accountable and making sure that you're getting the service that you're promised. And obviously, during the process of managing this migration, having a clear view of how your application is performing and making sure you have the proper capacity before and after that migration is really crucial to being successful. SLAs are SLAs. Businesses make commitments. People make commitments to other members of their business, or whether you get commitments from an outsourced infrastructure provider or a managed service provider. Those SLAs stay in place whether it's a virtual host, a dedicated host, or something out on the cloud. People need to understand SLAs. You need to watch them. You need to monitor them. This is the vocabulary that people use to have conversations about performance. Even before you go and do your load testing, it might not be enough to just load test before you do it to be able to maintain your SLAs. Again, just because of the things we talked about before, the complexity of applications, that you may not be able to completely replicate things in your production environment, in your pre-testing or your pre-production environments. So you need tools that can handle that as well. The other thing is, how do you know how your desktops are performing? What kind of response time are your end users? seeing. At the end of the day, it's response time that matters most. That's one of the things that I had recently heard from an analyst at one of the major analyst firms, and I think that's true. That your users don't care really about infrastructure and all the details of it. They just want to know that when they hit the send button on their browser, that the application functions and that transaction or that click gets them their information they're looking for quickly without having to wait a whole long time. And in the end, you want to know what your complete end-to-end performance is, not just from the performance of one component, but it's again the performance from when someone clicks the button on their browser, that transaction and that individual transaction goes from the browser across the network to your data center and back. End-to-end performance is a major contributor and the major thing you measure as you're trying to worry about performance. So as we look at traditional tools today, the tools that people use to manage their infrastructure, one of the greatest challenges has to do with the fact that we live in a siloed world, that many people both from the people who manage the systems in your IT infrastructure, along with the people who go out and as well as the tools that they use to manage things, are often very siloed. Someone who manages the application server may have a tool that's very dedicated to that specific application server. The DBA who watches the database may have a tool that's very crisp and clear and clean and understand what's going on with the database, but has no sense of what's going on around it. And that goes on down from whether it's the network management guys with their own net management tools, all the way down to the guys who manage storage. In this scenario, it's a pretty common scenario that people see in enterprise IT today, that an application, the person who owns the application or the person who's responsible for managing that application, whether that person is in IT operations or an application support role, may receive complaints from people that the application is performing slowly or not performing up as well as people want it to. Yet when this person goes out, the IT operations person goes out and asks the various stakeholders, the people who own the various components in that application, how things are performing, all lights may be green. The application server guy may look at it and see everything looks fine on my end. I'm not having any memory or CPU errors. The database guy looks at his tool and everything's fine, and we get on the chart. The storage guys as well as all the other pieces. At the end of the day, the application is slow, but you don't have a true end-to-end view of performance management and capacity planning, so that is a real risk when you're managing an application. So at this point, I'd like to hand over the control of the presentation to Rich Fraunheiser from Metron-Athene. He's going to talk a little bit about the 5 imperatives about APM and capacity planning. Welcome, Rich.
Frank, thank you. We're going to talk a little bit about the 5 imperatives. I'm going to get started with some of the capacity management, capacity planning related imperatives. One thing that Frank said that's incredibly important is that everything historically has been managed in a very siloed way. Imperative number 1 really deals with that. We need to change our mindset. We cannot look at silos and just assume the fact that silos are performing as expected. That means that our applications and our transactions are performing as expected. A shift to virtualization really does require a change of mindset. Technology is going to automatically move work from one server to another server. It's going to move work to pockets where there is adequate capacity to actually run that work. Having a proper amount of capacity on a host level really is no longer the focus. When I started in capacity management, and we're talking about the mid-90s, we worried about servers, and that was just the beginning of moving to servers. Before that, it was mostly mainframes. We worried about servers. We worried about whether or not our utilization was above a certain level. If we managed to keep utilization below a certain level, and that varied a little bit from application to application, we would assume that our end users were getting adequate service. That's no longer good enough today. We actually need to move from thinking about the host level. We need to step that up and think about a data center level, because that technology, the automation that drives a lot of our virtualization technology, actually will take that work and will move it from one physical host to another when it feels like it needs to. We need to ensure that we have adequate headroom for periods of peak demand. We don't really care about how much capacity is in place for periods where we do not have peak demand. The true nature of capacity planning is making sure that when we have these periods of peak demand, that we have adequate resources in place where we can continue to meet our service level agreements. The last bullet point on this slide, I think, is the most important. In my experience, virtualization provides savings only if it's properly capacity managed. I've been in a lot of environments where people have moved to a virtualized environment, whether it's VMware, Hyper-V, AIX, some other Unix-based virtualization. Virtualization left unchecked, if you have the same type of management in place in virtualization where you over-configure all of your hosts, you over-configure your environment, you over-configure your network, you over-configure the amount of storage, all you're going to do is spend increasing amounts of money moving to a different paradigm, moving to a virtualization paradigm. One thing virtualization does provide, and that technology that sits underneath does provide, is the ability to work at a higher level of utilization in your data center, because the technology is going to look for pockets of adequate capacity to move important work. But if you don't change that mindset and you over-configure your environment, all you're essentially doing is changing how you do the work. You're going to move from Windows to VMware. You're going to spend at least as much money, if not more, and you're not going to take advantage of what virtualization can bring to you. So capacity management is incredibly important in that area. The second imperative is having some type of a process-based or a service-driven approach. This is driven by the fact that we have shared infrastructure and resources. We have centralized storage in place. We have reliance on centralized network resources. Therefore, it's important when we do have any kind of incident, any kind of problem, that we have a mechanism in place, a process in place, where we can quickly resolve our incidents, quickly resolve our problems. When we're dealing with virtualization and shared infrastructure, and especially shared resources, the one thing that we end up dealing with now is if I have a particular incident that brings down a server or brings down a cluster, that might not only affect one application like it would have done back in the pre-virtualized world, it may affect everyone that's running on that cluster, everyone that's running in that data center. So having strong processes to deal with incidents, with problems, and ensuring that you have service level agreements defined and properly policed are incredibly important. So proper capacity management, what that does in this area, it ensures that you have fewer incidents, fewer problems. That only makes sense. You know, a significant portion of incidents and problems can be related to not having enough processing power, not having enough capacity. So proper capacity management can help you ensure that your service level agreements are met. Imperative 3, focus on services and service level agreements. Again, this is more of an IDLE-based approach. If you're not familiar with what IDLE is, it's the IT infrastructure library. It's essentially a group of processes where the service life cycle is the central focus. So we have a service that goes from the strategic standpoint in through a strategy, from the strategy standpoint into a development, into a transition into production, a production life cycle, and then continued improvement. The service life cycle is the central focus. The processes that support that service life cycle are incredibly important. Those include service level management. Those include capacity management, availability management. Service level agreements come out of this process. They need to be developed in such a way that they're specific, that they're measurable, that they're achievable, and most importantly, they have to be at an acceptable cost. We can probably provide 1-second response time in many cases, but it may be at such a cost that it's completely prohibitive, where 4-second or 5-second response time might be reasonable, and the end users would be more than happy with that. Our goal is to ensure that we have enough capacity, but not too much capacity to meet the service level agreements. Our goal is to meet the service level agreements at an acceptable and controlled cost. And our focus needs to be there in a virtualized world because the capability of overspending is certainly there. Sliding into the APM space, into application performance management, measuring those end-to-end transaction times for production transactions, that's absolutely critical to see if service level agreements are met. If you set a service level agreement that says 95% of your transactions are going to be completed within 5 seconds, if you don't have a tool in place that measures that end-to-end response time, then it's a poor service level agreement. Because if there's no way to measure it, if there's no way to police it, there's no reason to have it. And most end users, most customers of your organizations want to set those service level agreements in a way that's meaningful for those customers and those end users. When service level agreements are not being met, it's important that you have the ability to predict and model scenarios to determine the appropriate infrastructure changes so that in the future you can meet those service level agreements. The APM data, the application performance management data, that helps you find opportunities to right-size virtualized infrastructures. If you're not meeting those service level agreements, if you're close to not meeting those, if the amount of transactions that you're completing is increasing and trending to the point where you can see scenarios where you're not going to meet your service level agreements, that type of data then helps you find opportunities to build capacity planning models to right-size your virtual infrastructures. The next few slides talk a little bit about APM and capacity data integration. What we see here is a combination of Sharepass data being fed into Metron's capacity management solution, which is called Athene. Athene has what we call a capacity management information store. That's the idle phrase for essentially a centralized place where capacity and other performance data can be stored. So in that kind of a database, we would have data such as your typical utilization data. You know, our CPU utilization for a server is 90%, and we have 21% free storage available based on the view of the operating system. But what we can also put in that capacity management information store is data from a tool like Sharepass, where we get end-to-end response time data for particular transactions for particular applications. The correlation of this data and the combination of this data can be crucial for making capacity management decisions. Here we have an example where we have response times that come from Sharepass. You can see that there's a warning and an alarm threshold set on this particular chart. We have the warning threshold set at about 2¼ seconds. We have an alarm threshold set at 2½ seconds. And that's where the SLA breach happens. And you can see that in this particular application, the SLAs are not being met during the business hours from 8 o'clock until 4 o'clock in the afternoon. This is the kind of data that's important because when we aggregate this data, we're able to see now exactly where we need to look at our capacity, potentially provide more capacity, or potentially move our workloads around or change the way our infrastructure is engineered so that we can provide good service throughout the day. The other opportunity here, of course, would be to go back and say, this is what we can do for this particular cost. Perhaps we need to renegotiate our service level agreements in order to cut costs. Maybe we don't provide that 2½ second response time during the business day. Maybe that 4-second response time is adequate. The key thing here, though, is that we have the data, we have the information, that we can actually make some intelligent decisions based on that data that's captured and stored. The next chart that I'm showing here just shows a number of transactions by particular type. So we have the number of transactions aggregated, customer attribute, application transactions, equity order transactions, order routing transactions, risk analysis transactions. Again, important data that goes into a capacity management information store, but this is the type of data that's readily available from Sharepass, because Sharepass is able to take the types, the number of transactions, you're able to build those into certain types of transactions, and that data then becomes incredibly valuable when you're looking at your transaction mix throughout the day. If you find that a certain type of transaction is there are many more transactions for a particular type of transaction, for particular hours during the day, then maybe we need to focus on that and provide good capacity management decisions for those particular time periods. When I mentioned correlation earlier, this is an example of correlation between the amount of CPU usage for a particular server and then the average response time for work that travels through this server. You can see that as CPU increases above 50, 60%, that the average response time for this particular type of application goes up dramatically. It goes from 2 seconds when we're below 50%. It goes up to anywhere near 4 seconds when we get up to 80, 90%. And as we get closer to 100%, that's only going to get worse. So this is something that we can use to help us set thresholds for CPU utilization for servers. It helps us manage our virtualized environments as well, letting us know how much headroom we need in case we do have situations where there's additional work, unexpected work that's being run through the virtualized environment. Finally, the last chart I wanted to present here has to do with, again, the number of amount of work that's being done on particular servers. So here we have two different types of transactions being run through the same server. One is online trading, one is e-banking, and the number of CPU seconds that are being completed at any particular interval is being shown here. And you can see that in different times of the day, the online trading is considerably busier than the e-banking. But this is the type, again, of transaction mix that's incredibly important for you to make good capacity management and good decisions for your applications and your service level agreements. And I'm going to pass it back to Frank at this point.
Great. Well, thank you, Rich. I appreciate it. Appreciate the informative slides there. And it does come back to, as we talked about earlier in the presentation, really understanding your entire IT environment. Knowing how things flow from physical to virtual, knowing your true end user experience. And as Rich was saying, both performance and capacity matter in this new virtual environment. And since it is moving to a new environment, you need to make sure you know what's going on in both places. One of the things you can do as well with Sharepass is keep an eye on what are the things that are your weakest transactions, what are your weakest processes, what are your weakest components, what are your top 10 killers as we describe it, what are the applications that are creating the greatest problems in your environment to help you prioritize troubleshooting and get to the root cause when there are complaints about things running slowly. And finally, at the end-to-end point of view, having that knowing what specific components, because any particular transaction, particularly if you're in a load-balanced environment or a shared service environment, you can see that any one given transaction can flow through a number of different components to get to achieve the same process. So knowing where the problems can arise is really pretty important. This is an example of also understanding by location. In this case, this is an example of where a distributed business has different offices around the country. And this is, I was talking to a client of ours recently who had this problem, and they had different locations, and some of the locations were complaining about performances, and some others weren't. They had options of complaining about the application. They could complain to the WAN vendor. They could check on the desktops. There were a whole lot of different places, and by using a product like Sharepass, you could have a clear view of the service level at the location, as well as the breakdown where across your infrastructure, what component, what part of your infrastructure is contributing to the slow performance of that given application. So in summary, as we've talked about before, virtualization presents a lot of opportunities, both in scale and cost, but also can bring many new challenges to your business, whether you're migrating it or it's just a core part of your application environment. You need to think a little differently when you're managing, whether it's managing capacity for the future or managing performance today. Today's siloed tools just are not adequate to be able to do all the things you need to do and manage your performance and maintain your service level commitments. Something to think about as you go forward is, and certainly Sharepass, we showed some examples of how Sharepass, along with Athene, using the data that comes out of Sharepass, can help you optimize your capacity management as well as track transactions and understand your full application performance. By using this performance data, the granular performance data for 100% of your transactions from Sharepass, you can better capacity manage for the future and the present. With that, I wanted to open things up for questions. I don't see any questions right now, but I'll pause for a brief moment. Again, if you have any questions, please feel free to submit them in the chat window in the GoToMeeting session. If you'd like to learn a little bit more about the products we talked about today, you can visit Metron-Athene.com to check out their capacity management products, their Athene capacity planning, capacity management products. You can also go to Correlsense.com and check out Correlsense Sharepass product. There is a free version, Sharepass Express, that can be downloaded directly from Correlsense.com. Or if you'd like just to talk to someone on the phone to get a quick demo of how the products work, please feel free to email us at info@Correlsense.com or check out realusermonitoring.com as well for Correlsense. Well, I don't see any questions, so on behalf of Rich Fraunheiser and everyone at Metron-Athene, as well as myself and my producer, Tom McEwen, thanks, Tom, for another great job on the other end. Thank you again for joining us, and have a great day.